Okay, so let's talk about basically, let's go over this pH stuff. Really, pH is just a fancy word for measuring the H plus concentration in solution. And we know that acids make H plus, so H plus is related to the acidity. Now, it turns out that there is an equilibrium process in water, that water by itself will split up. Two waters will split up such that one is an acid and loses an H plus and becomes OH minus, and that H plus sticks to another water, which is the base, and we get H3O. So these are always going to be in equilibrium. In any drop of water, any beaker of water, if it's only pure water, I expect that if I multiply, because this is my KW formula, I have two aqueous species. The products are concentration of H3O plus and concentration of OH minus. When I multiply them together, that gets me my K expression. And I've measured this before, or scientists have, and found out that it's 1 times 10 to the negative 14. So what that means is the ions are in equilibrium in water, always, in any solution. And if I multiply the concentration of hydroxide ion by the concentration of H plus ion, the answer will always multiply up to be 1 times 10 to the negative 14. So if I know one, I know the other. Now, if I have equal amounts, turns out that they're both going to be 1 times 10 to the negative 7. So how would I get them to be unequal? Well, if I add extra acid, then that extra acid is going to be reacting with the water. Remember, add extra acid. We talked about this with Le Chatelier. I'm adding product. It's going to shift to make more water, which is going to end up reducing it. I will still have the concentration of OH minus times the concentration of H plus will still be equal to 1 times 10 to the negative 14, but now they won't be the same value. I can do the same thing if I add base. I can have, I'm going to add base. It's also going to shift back and make water. Now, at this point, I will still have OH minus times H plus. The concentrations will still multiply together to be 1 times 10 to the negative 14th, but I'll have more OH minus than H plus. So the only thing that's true that always is that when I multiply them together, they will be 1 times 10 to the negative 14. So we really come up with this little cheat sheet. Acidity is how much H plus ion is solution, because acids make H plus. If the H plus concentration is more than 1 times 10 to the negative 7, we say the solution is acidic. But if I know the H plus concentration, I also know the OH minus concentration, because they have to multiply together to be 1 times 10 to the negative 14. So it could also say that since the OH minus is, if it's less than 1 times 10 to the negative 7 molarity, that's also a way of saying something's acidic. I can also talk about it in terms of the OH minus ions in solution. If there is more than 1 times 10 to the negative 7 OH minus ions, concentration of OH minus ions in solution, I call that basic. I could talk about that in terms of H plus too, because H plus is related to OH minus. So I could say if the H plus concentration is less than 1 times 10 to the negative 7, that's another way to describe the solution being basic. If I have equal amounts, they would be equal to 1 times 10 to the negative 7, because they have to multiply together to get 1 times 10 to the negative 14, I would say that that is neutral. As you can see, I'm kind of getting tongue-tied talking about all these 1 times 10 to the negative 14th, 1 times 10 to the negative 7. It'd be awfully handy to deal with numbers that are smaller. And that's where logs come in. If you remember your math, the log is just saying, I don't really want to deal with the whole number. I just need a general idea of the size of the number. Is it really, really big, or is it really, really small? It's about the exponent. If I write it in scientific notation, it's the exponent. So look at these different values I could have for H plus. I could have 0.01, which in scientific notation is 1 times 10 to the negative 2. I could have 0.00000000001, much smaller number, and it's 1 times 10 to the negative 12. I could also have some number that doesn't have ones in it, 0.0065, which could be written as 6.5 times 10 to the negative 3, or I could write that as 1 times 10 to the negative 2.19. The unevenness of this number is how the 6 and the 5 kind of pull into it. Now the log would be just look at the exponent. So I'm looking at the negative 2, I'm looking at the negative 12, and I'm looking at the negative 2.19. And what I see is, if I have a really big number for the log, it's a really small concentration. This is a very small number. This is a fairly big number, and it has a very small log. So it's just a way of saying I can get rid of that long scientific notation number and just talk about the relative size in an order of magnitude. Since OH minus and H plus ion are related, if the OH plus concentration was 0.01, these two have to multiply together to be 1 times 10 to the negative 14. So I'd figure this one out to be 1 times 10 to the negative 12. It would be negative 12. So notice that when the exponent for the H plus is pretty low, this is pretty high. When I'm saying high and low, I'm meaning the size of the number, I'm ignoring the negative sign. And I could do the rest for these. So the logs is just a nice way to deal with just the size of the exponent, and I get to more normal size numbers. Note that if we define the pH to be the negative log of the H plus, not only do we get rid of the whole scientific notation, we also get rid of the fact that it's negative. And I'm dealing with numbers like 2 and 12 and 2.19 and 11.81. Much easier numbers to deal with. That's why we like logs. So when I talk about pH, we could have defined it on the last page as anything that has the H plus concentration. When we talk about acidic, anything that has an H plus concentration between 1 times 10 to the 0 and 1 times 10 to the negative 7. Another way of saying it is anywhere with a pH value of between 0 and 7. So my pH is defined as the negative log of H plus ion concentration. So I'm going to play around with math. I'm going to multiply a lot of stuff, rearrange a lot of algebra equations, and I get a whole bunch of equations. Basically, all of these things are related together. I certainly already had this one, 1 times 10 to the negative 14th equals the concentration of H plus ions times the concentration of OH minus ions. And because that's saying this, I say that the exponents have to add together. This exponent over here is negative 14, so the log of it, negative log of it would be 14, has to be equal to the sum of these exponents, because I remember my exponent math. So that's where we get this. The sum of the pH and the pOH always has to equal 14. Again, this is reminding me that the definition of P of anything is the negative log of that anything. So pH is negative log of H plus concentration. pOH is the negative log of OH minus concentration. So I'm going to play around with those 3 equations, and from that I have about another 10 equations. These are all rearranged to tell me about solving for H plus ion concentration, which remember is the same thing as H3O plus the ion concentration. So I could replace all these, the H plus with H3O plus. And these have all been rearranged for OH minus concentration. So effectively, give me one, I can kind of give you all the others. If I know the pH, I can find the pOH. If I don't know the pH, but I know the OH minus concentration, I can find the pOH. If I know the H plus concentration, I can find the OH minus concentration. But if I know the OH, if I know the pOH and I want the OH minus concentration, I take 10 and raise it to the negative pOH power, and that will get me the OH minus concentration. So I basically, based on what I'm looking for, what I need to discuss, what I want to be describing, I have a variety of equations, which kind of says, give me any number describing the solution. You can give me the H plus ion concentration or the OH minus concentration. You can give me a pH, you can give me a pOH. They're all related. And I can make terms of acidity. Generally, acidity is described in terms of pH because that's our typical scale. So it's somewhere between 0 and 7 would be an acid. 7 would be neutral. Between 7 and 14 would be on the base. But I could also say that in terms of H plus concentration. If the H plus concentration is 1 times 10 to the negative 7 molar, I call that neutral. If it's bigger than that, anywhere between 1 times 10 to the 0 and 1 times 10 to the negative 7, so exponents between negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6, that would be considered acidic. Same thing on the basic side, only in terms of H plus ion concentration, I'm looking for exponents in the concentration of negative 8, 9, 10, negative 11, negative 12, negative 13, or negative 14 would be basic. If I'm talking about OH concentration, remember OH concentration is related to H plus concentration, but when the H plus concentration is big, the OH concentration has to be small, because when I multiply the two numbers together, they always have to get me 1 times 10 to the negative 14. So I can talk about it in terms of OH minus concentration, and if I'm doing a lot of work with stuff with OH minus ions in it, I might choose to talk about POH as a way of describing the acidity or basicity. So I can use any scale that I want for any of these 4 factors. They're all related.